Hello and welcome. Today, we are going to stare down a mathematical beast. I'm talking about a problem that looks, at first glance, completely impossible. But we're going to crack this colossal equation, and in the process, we'll see how even the most intimidating challenges can have a surprisingly elegant solution.
So meet our antagonist for today. This is a ninth-degree polynomial. And just look at those coefficients. We're talking numbers in the hundreds of thousands. I mean, honestly, just looking at this thing is enough to make you want to just, close the book and walk away. It's long, it's complicated, and it looks absolutely impenetrable.
Seriously, just take a second. If you saw this, where would you even start? Try to factor it? Guess the roots? The sheer size of these numbers makes all the usual methods feel like trying to empty an ocean with a teaspoon. It's a classic case of just pure mathematical intimidation.
But like in any great mystery, this one has a key. There's a hidden pattern buried inside all that complexity, an unexpected clue that can unravel the entire thing. We just have to know where to look.
And here it is. This is our secret weapon. The source material points us to a very specific tool, a discriminant formula. Now, don't worry, you don't need to have this thing memorized or even fully understand how it works. The important part is that a specific, powerful method exists that was designed for exactly this kind of problem.
So what's the game plan? Well, we're just going to follow the instructions. We're going to apply this formula, step by step, to our monster polynomial and just see what happens. This is where the real detective work begins.
And the process is actually surprisingly simple. It's methodical, it's repetitive. We're going to test an integer k all the way from 0 to 9. For each one, we'll plug the coefficients into the formula and see if the result is 0. Think of it like we're turning the dials on a combination lock, one number at a time.
All right, let's turn that first dial. We'll set k equal to 0, run the numbers, and see if our special key fits the lock. Let's find out.
And boom! Right away, we get a payoff. The formula takes the first couple of coefficients and spits out two values, -36 and +36. They cancel each other out perfectly, leaving us with a clean, beautiful 0. There it is, a perfect 0. The first dial on our combination lock just clicked right into place. That's one down, 9 more to go.
Okay, that was pretty satisfying, but was it just a fluke? A lucky coincidence? Well, there's only one way to find out. We got to keep going. Let's turn to the next dial and test for k equals 1.
And no, it was not a fluke. For k equals 1, we plug in more of those gigantic coefficients, and what do you know, the formula once again gives us 0. The second dial clicks into place. Okay, now we're talking. A pattern is definitely emerging here. The formula seems to be working every single time. So let's just run through the rest of the values for k and see if this pattern holds up. All right, for k equals 2, we get another 0. The third dial clicks. Next up, k equals 3, and it's the same story. The calculation is different, but the result is exactly the same, a perfect 0. And how about k equals 4? Yep, you guessed it, the formula holds true again. And for k equals 5, this systematic approach is really paying off. No surprises here. Let's check k equals 6. The numbers are getting bigger, but the formula handles them without a problem. Another success.
Okay, moving on to k equals 7. At this point, the pattern is just undeniable.
We are so close now. For k equals 8, it's a perfect match. And finally, the last test for k equals 9. Success! Every single dial from 0 all the way to 9 has clicked perfectly into place. The combination lock is open.
So, what was all that work for? Well, by getting a 0 every single time, we've just confirmed that our polynomial has a very, very special property. And now it is time for the big reveal, the moment all this detective work really pays off.
And this is it. This is the magic. Because that formula worked for every value of k, it means that almost all of those terms in our original monster equation are, well, they're just noise. They all cancel each other out in this hidden, beautiful way. The colossal 10-term beast on the left collapses into that wonderfully simple 2-term equation on the right. We went from a nightmare to something you could solve in seconds. That's the power of finding the right key.
So let's just take a step back and really appreciate what just happened. This was never just about solving one tricky math problem. This little journey we took shows a much deeper truth about how we can approach complexity, really in any field.
So, what's the big takeaway here? First, that even the most intimidating problems can have an elegant key just waiting to be found. Second, having a systematic method is an incredibly powerful way to cut right through the noise. And finally, that at its heart, mathematics is really just this beautiful search for the hidden patterns that make our world simpler.
And that leaves you with a final thought. We just watched a seemingly impossible equation basically dissolve when we applied one specific formula. It really makes you wonder, doesn't it? How many other problems out there that we think are impossibly complex, in science, in technology, maybe even in our own lives, are just waiting for someone to discover the right key?